Damania, and I am a software developer at Pecos Data Systems. In today's video, I am going to discuss the work we do at Pecos Data Systems, what is Pecos Data Systems, and our software service in detail. So without any further ado, let's start. We at Pecos Data Systems perform autonomous inspections of utility poles and wind turbines with the help of drones, and we aid manual inspections by reducing the need of a subject matter expert by using our software to perform the entire inspection process of utility poles and wind turbines using AI and machine learning. As you can see on your screen, the entire architecture of Pecos Data Systems. Let's go through the architecture of this Pecos Data System before we discuss our software service. As you can see, a drone is used, a DJI commercial drone is used for acquiring the images captured from the utility poles and wind turbine inspections. These images are in its complete raw form and are high quality images. We use these images to identify any types of damages or any types of disasters that have been taken place on these utility poles and wind turbines. Moreover, these images captured through the drones can be used to identify the objects on a utility pole. Using these objects which are identified on utility poles and wind turbines, we maintain an entire database of each and every utility pole and the number of equipments and what equipments it carries. This helps in better keeping check of the entire inventory of any system, and also with the help of these images helps us identify any kind of damages which then can be streamlined and then solved. Our system then also makes use of geospatial mapping and weather data which is captured from the GOES 16 satellite. This geospatial data that is captured from lightning data which is captured from the GOES 16 and NOAA satellites is then used to identify the areas which could be struck by lightning, thunderstorms, or severe weather, and then can be used to make informed decisions of where the inspections are to be conducted. This not only saves resources but also implements a very good architecture and also reduces the amount of resources needed for inspections, hence increasing the efficiency of every inspection. We then use human equipment and conditional tagging with machine learning and AI. As I mentioned, we help tag each and every piece of equipment on the utility poles. The list of these tag equipments are then put into a well-structured database which helps the companies and clients keep track of their utility poles and the equipment that it has on it, which helps in better maintaining them. In this way, we provide an entire cloud-based data service to our clients. How do we do that? Let's see that in detail. So as you can see in this architecture diagram, a drone flies over each and every utility pole or wind turbine and captures images which covers each and every single aspect of these poles and wind turbines. After capturing these images, an ingestion algorithm is used to take the data from the drones into our system. The data which is captured is then cleaned for any kinds of outliers, noise, or inconsistencies, and then using this clean data is passed to an algorithm, and that machine learning algorithm and then helps identify each and every piece of equipment on that. Then an image classification algorithm is used to classify any kinds of damages on these kinds of utility poles and wind turbines. Finally, an end user UI, which is interactive, is used to show the user, that is the clients, what the damages are and how these damages can be solved. So, moving on, as you can see, the first step after capturing the images from the drone is to identify to annotate these images. What we do at Pecos Data Systems is that we have a huge corpora of a huge image data set which consists of different types of utilities, poles, wind turbines, etc., captured over a huge number of time on different number of locations. We then used all these images to manually annotate each and every piece of equipment which is found on it. A total of 21 different types of equipments were found only on utility poles. We annotated each and every of these equipments and trained it over a very sophisticated object detection model and image classification model. This helps us to identify any unseen utility pole or wind turbine and identify the equipment on it and identify the different kinds of damages it can possibly have. After conducting our tests, the result that was obtained was pretty generous. The graph that you can see right now in the video is the accuracy graph obtained versus the number of steps that were taken by the neural network. And as you can see that only on 60 images the accuracy yielded was over 70%, of a little less than 80%, and that is only 60 images. So this shows how good the algorithm works, and in a number in number of times when we have a huge amount of data set, we'll have more accuracy. Moving on, as you can see, this is how our algorithm works. As you can see, it is a prototype of our system. The image that you can see right now in the video is a confusion matrix. This confusion matrix shows the number of correctly and incorrectly identified image, and over a huge set of images we saw that only a few images had a few inconsistencies, which can be solved when we have more data. It's a pretty excellent model. It correctly identifies each and every equipment on the utility poles. It identifies each and every object, and then it identifies the damages that is on them. Once each and every equipment has been identified, the damages have been identified through our algorithms, we then provide the end user a user interface where the user can track the inspections. For the purpose of tracking these inspections, we have made use of a software called Scopedo. Scopedo is a very sophisticated software for maintaining your inspections. Each and every image captured from the drones are geospatially tagged, which means that not only the image can be viewed as is, but also the different metadata related to that image is also captured through our drones. One of the important metadata which is captured in these images is the location of the image taken, which helps us keep track of where the image was taken for which particular utility pole or wind turbine. The user is not concerned about any of the back-end services that we are working on or that we provide on, but is only concerned about the user interface that is provided. It's a very easy to use interface which has a lot of features for management of inspection, for reporting the inspections, and for just tracking their utility poles and wind turbines. The user interface that you can see right now in front of you is Scopedo, and as you can see, this entire long list of things that you can see here is the different inspections which you can keep track of. To go into a particular inspection, you just have to click on it. Once you click on the inspections, you see a satellite view of your inspections. The number over here on the map overlay indicates the number of utility poles or equipments that have been inspected. 7 here, as you can see, there's the number 7 here, which means that there were 7 different pieces of utility poles and equipments that were captured at this particular location. You can always go and click on these images and further expand them on that geographic location, and you can then have a more closer look at your inspections. On clicking any of these things, you can see the exact location of the utility pole where the image was taken, and below here you can see the image which was captured from the drone. There it is. You can always go back into the inspections and now track another inspection. So as you can see, this again is another satellite view of an inspection which was taken somewhere in Dallas. Now, once you click any image, you can not only look at the image that was captured on the drone, but the exact location of that image which was captured. And there it is. A user can further go and add map layers, can go and create an embedded link to that image. If the user wants to give a link to a report for that image, then it gives the user the flexibility to do that too. The user can also further use the annotation tool and go ahead and annotate any images for any kinds of annotations that the user needs to make. There you go. And then you can go and select the annotation type. We have a huge number of annotation types, right from power lines to solar, roof, wind, bridge, etc. Each annotated section has different kinds of damages that it could have. If there is a damage which is not listed in this, you can always go ahead and create the damage for it. So yeah, that is the entire software service provided from scratch to the total end process, where the user can track, where the user has not needn't be concerned about anything. All they have to do is inform us where they need to provide the inspection. We send our drones. The drones capture the images. These images are then trained um, on an object detection and object classification model. And this model basically is a TensorFlow. This model is basically developed using libraries in TensorFlow and Python. Each image is annotated on the annotation tool as discussed before. That is this. This annotation tool basically annotates each and every image. This image is then converted into an XML file. The XML file is then converted into a TF record, and that TF record is then used in the classification process. On these TF records, the entire algorithm is trained, optimized, different steps are taken, number of epochs are taken, hyperparameters tuned, and finally the result is obtained, which is on Scopedo an entire summary of your inspections, the different images captured, and a report indicating the different damages that have been taken place. The different objects based tailored on the needs of the user. The database can be tailored again based on the needs of the user. So if the user wants a relational database, then we create a relational database for the user. If the user wants a document-based database, then we can do that using, well, in any format, maybe JSON or XML, whatever. So we customize the entire schema of our data based on the user. So thank you so much for listening to this entire process. If you have any questions, please reach out to us and we'll be happy to answer them. Thank you so much.